Hello. In this video, I will go over a quick preview of the three techniques for dosage calculation. And I will review the significant figures. We're, what we're going to do, I'm going to introduce you the three techniques of dosage calculation. So, and then the next video, we'll actually do examples finding dosage calculation using those th three techniques. But first, before we go over the techniques for dosage calculation, I want to go over significant review. I mean, not significant figures, and I want to make sure we get we get our numbers right because that's very important when you're doing dosage calculation. So let's briefly go over significant figures. So if you probably took chemistry, you probably know a few things about significant figures. So significant figures review. So just note, rule one, non-zero digits are always significant. So anything that's non-zero, for example, 3, 4, 5, they're all significant, right? Uh, rule two, zeros between non-zero digits, captive zeros are significant. So yeah, zeros between non-zero digits, for example, 1002, are significant. Now, even if without a decimal, they are still significant. So, for example, 1002 has four because these two zeros are significant because it's between one and two, right? So, yeah, rule three is also important. Leading zeros to the left of the first non-zero digits are not significant. They are placeholders. So that's also important. So 0.0052 only has two sig figs. Even though it has a decimal, these leading zeros are not significant. So let's talk about zeros. You have zeros in front of the non-zeros are leading, and then the next zeros, um, trailing zeros to the right of decimals are significant. So yeah, trailing zeros to the right of the decimal point are significant. For example, 12.000 has four significant figures. Okay. Rule 5, trailing zeros in whole numbers without a decimal are ambiguous. Okay, so this is also important. So an example, if you look at rule 4, 12.0, trailing zeros are only significant if you have a decimal. So if it without a decimal, they are not considered significant. So for example, 540 has only two sig figs. Even though 0 is a trailing zero, there is no decimal. So if you compare 12.00, the reason why these trailing zeros are significant because it has a decimal. And then 540 dot or 50 with a decimal has three sig figs because this zero is now significant because of this decimal. So yeah, trailing zeros are significant if it has a decimal. So looks so if we look at our examples, the numbers of 123 has three sig figs because they're non-digits, non-zeros. 0.0112 only has two sig figs because these zeros, those leading zeros are not significant, right? 5.00 has three sig figs. These zeros are trailing, but the thing is there is a decimal, so that's why they are significant. If it was just 500, it would only be one sig fig. So the next one, 2000 or 200 only has one sig fig because um even though these are trailing zeros, it doesn't have a decimal. Now, if it was 2.000, it would now be four sig figs, right? Okay. Okay, next one. So when adding or subtracting, use the fewest number of decimal places. So For example, 10.1, so when you're adding or subtracting, adding or subtracting, it's not about the largest, or it's not the one with the lowest amount of sig fig. It's the one with the fewest number of decimal points. So this only has one decimal. This has two. So you're only going to use the one with the fewest. So you're going to end up with one decimal. So when you add them up, don't you have 17.53. But because we only have one decimal, we're only get around to one decimal, so 5. And then you look at the neighbor, 3 is not greater than 5, so you do not round. Okay. When multiplying or dividing, use the fewest number of sig figs. So when you're multiplying or yeah, dividing, use the total or not the total amount of sig figs. So it's not the lowest amount of decimal. It's the lowest amount of sig figs. So 4.93 only has 3. 6.027 that has 4. So you're gonna only round to 3 sig figs, right? So go ahead and multiply it, and then this would be the third sig fig. And then you look at the neighbor, one is not 5 or beyond, so that's why we rounded to 29.7. So let's do a quick quiz to see your knowledge about sig figs. So quiz, state the number of sig figs of the value. So example one, we have 0.00004050. How many decimal places do you think that's going to be? What do you think? So trailing zeros are never significant. I mean, leading zeros are never significant. Trailing zeros are only significant if there's a decimal somewhere between. So you could forget about these zeros. They're not significant. So you have a total of one, two, three. You're gonna have 4 sig figs. Well, didn't you say trailing zeros aren't significant? That's true, but only if they don't have a decimal. Because we have a decimal right here, these zeros count as a significant figure, right? So you have 4 sig figs. What about example two? 54,700. Let's see. There's no decimal, there's no leading zero, there are trailing zeros, so there should be a total of, I'm going to say 3. So because there's no decimal, this is a comma, not a decimal. Because there is no decimal, these trailing zeros don't count as significant. So this is significant, this is significant, these aren't significant anymore because there's no decimal. So there's 3 sig. Example 3, we have 100.09. We don't have any leading zeros. We do have some trailing zeros, and there is a decimal, so there should be a total of 1, 2, 3, 4, 5, 6. 6 sig figs. Okay, question 4. We have 0.039. Let's see. There are trailing zeros. These are trailing. They're never significant, even if there's a decimal. So there should only be 2. Okay, so these are all review. It's going to be very helpful when we do our calculation dosage. So let's continue now. Let's look at this one, 5.4589 minus 2.33. So the rule is when you're adding or subtracting with decimals, it's not the lowest amount of sig figs, it's the lowest amount of decimal places. So over here, this has a total of 1, 2, 3, 4. 4 decimal places, and then over here there is a total of 2. So go ahead and do your calculations. I mean, go ahead and put this in the calculator. Don't worry about the sig figs, and you get 3.1289, right? Then what you're going to do is we're only going to have 2 decimal places because this is the lowest amount. So this 2 would be the second decimal place. And then what you do is look at the neighbor. 8 is definitely 5 and beyond, so you're going to round it to 3.13. Okay. So should we, yeah, we should have two decimals. Okay. Question two, go ahead and add them up using a calculator. And what you get is 20.672. Then what you do is count how many decimal places. This has three. This only has one. So there's a total. Your answer should have only one decimal place afterwards. So this would be six. You look at the neighbor. It is definitely seven is definitely five and beyond. So it's going to be 20.7. Okay. Question three, 2.33 times 18. So it's no longer, we're multiplying. So we count the lowest amount of significant figures, not the lowest amount of decimal place. So this one, 2.33 has three sig figs. 1.8, I mean, 118 or 18 has ex exactly two sig figs. So go ahead and multiply it out and you get 41.94. So we should only have a total of two sig figs as a final answer. So one would be the second sig figs, and then you look at the neighbor, it's definitely five and beyond. So it's going to be rounded to 42. And you're going to have two sig figs. Okay, the same thing with division. You count the lowest amount of sig figs. So go ahead and just divide 31.9 over 7.318, and you get 4.35911145. And then let's count how many totals the lowest amount of sig figs. So 3.13, I mean 31.9 has three, 7.318 has one, two, three, four. So we should round to only three sig figs. So five would be the third sig fig. You look at the neighbor, and then it's definitely going to, it's five and beyond, so it's 4.36. So when we're doing um, calculation dosage, just remember if you're less than 1 milliliter, you're going to round to the nearest hundreds place. So yeah, for example, if you have 0.567 milliliters, which is one, it's technically less than 1 milliliter, you're going to round to the hundreds place or the second place. So this would be the hundredth place, six, and then you look at the neighbor. Six is definitely bigger. Seven is definitely bigger than five, so you round it to 0.57. And if it's greater than 1 milliliter, you're going to round to the nearest tenth place. So, for example, 1.2 milliliters. Two would be the tenth place. So you look at the neighbor. It's definitely five is definitely above, so it's going to be 1.3. Question three. I mean, so pediatric dosage are extremely precise, awesome, often rounded to the nearest hundredth. And then when you're dealing with tablets slash capsules, usually you round to the nearest half or whole tablet. Okay. And if you still aren't sure, just always ask your professor or your colleagues, right? If you're not sure. Safety rules, never use trailing zeros when you are, yeah, so for example, you're going to write 5 milligrams, not 5.0 milligrams to prevent tenfold errors. And always use a leading zero. So yeah, that's also important. You always use a leading zero. So for example, 0.5 milligrams would be considered wrong if you just write it as zero point 0.5 milligrams. So yeah, always put that leading zero. Okay, so now you know about a little bit of significant figures and uh yeah, rounding. So let's briefly go over the three techniques for dosage calculation. So we're only going to do, we're briefly going to go over this. In the next video, we're going to do plenty of examples of dosage calculations. So method one um, is called dimensional analysis. And with dimensional analysis, one equation leads to the answer. Factors, units of measurement are placed so that like cancels, so that like can units cancels out and the desired units of measure remain. So you probably remember this from stoichiometry, right? Um, or yeah. So it's where you set up as a fraction. So yeah. So remember, if you want to go, for example, if you want to convert feet to inches, you're gonna put feet on the bottom and then inches on the top. So it's kind of like stoichiometry. And when you're multiplying fractions, you always multiply across. Okay. So yeah. So we know that 1 feet, there's 12 inches. So right, let's pretend this is 5 feet. And then yeah, so make sure you, when you're multiplying fractions, multiply across. You can represent multiplication several ways. You can write it as parentheses, or you can put that x. So for example, you could do 5 feet times 1 feet over 12 inches. And then if it's good to write 5 feet as a fraction, so there's nothing under five, so you always put an invisible one. So if there's nothing under the number, there's always an invisible one. And then you always multiply across. Okay. And you can also write it as a parentheses. It's really up to you. It's your preference. You can write this as 5 feet parentheses over one, and then you can do it like a little dot and then parentheses fraction and then 1 feet 12 inch, right? You could do that. That's perfectly fine. Or you could just write the X. Just note that the units, so the feet goes away and then you just multiply across. Okay. So what are the disadvantage of using this method? You need to place your units of measurement carefully. It matters what is on the top and on the bottom. So yes, that does matter so that you end up with the units you are looking for. So write down the ordered dose, basically what you have, multiply the conversion factors if necessary, multiply by what is available by sh being sure that you are looking for tablets, milliliters is on the top. So I'll explain when we do an example, and then cross out units and solve. So for example, you're gonna set it up. Let's say you have 0.5 grams, and then we somehow have to convert it to tablets. So you're gonna put grams on the bottom, and then there's something usually you'll have a sheet, or on the next video I'll talk about how to do the conversion. But we know that 1 gram is at 1,000 milligram, and then one tablet has 250 milligrams. So as you can see, right, we are multiplying across, and see how this gram is on the top and then this gram is on the bottom. That's what you want if you want to get rid of the grams, right? And then you see how this milligram is on the same top and then on the bottom. That's what you want because you want the milligrams gone. And then you want your known variable. We want it in tablets, so we put that on the numerator. So the grams disappears, the milligrams disappears, and your final unit will be tablet. And then all you got to do is we are multiplying fractions, so you multiply across. So if you put 0.5 times 1 times 1, um, that would be what? Let me do that real quick. So remember, when we're multiplying fractions, you multiply across. So what's 0.5 times 1,000 times 1? That's exactly 500. And then you do the same thing with the bottom. So multiply across. What is 1 times 250? That would be 250. And then our units will be tablet because these grams disappears. So does the milligrams disappears, right? And then what's 500 divided by 250? It's exactly two. Now, we don't have to put a trailing zero because when we're dealing with tablets, you round to the nearest tablet. So our answer would be two tablets. Okay. I really like this method. I also like the ratio and proportion. So yeah, I like this method as well. So let's go over method two. Method two is the ratio and proportion. I like this method too. Um, so ratio and proportion compares the known ratio such as concentration to a second ratio with the unknown value. So you would cross multiply and it's then used to solve for unknown values. So advantage, you have the flexibility on how to set up the ratio. Example, what you put on the top and the bottom is. It's flexible versus dimensional analysis. Disadvantage, more steps are required to use this method for many dose calculation problems. So make sure units of measures are the same for the ordered dose and available dose. If necessary, convert a unit measurement for the ordered dose prior to the setting up the equation. I'll explain. Where was I? So advantage, you have the flexibility. How does okay? So disadvantage is more steps are required to use this method for many dose calculation. Oh, I already just went over that. So make sure place what is available on this on one side of the equation. Example, available dose and available from the form slash amount. Place what is ordered on the, okay, so this sounds really confusing, but it's really easy. Here, place what is ordered on the other side of the equation. Example, order dose as an X for the unknown amount. So this is what you got to do. So when you're doing ratio and proportion, this is how you would set it up. You set it up as an equal sign in the middle, and then you're going to put two fraction signs. So you're going to put one fraction sign on the left and then one fraction on the right. So when you're dealing with proportions, you can set it up any way you like, right? So you could put, for example, in this one, you could put milligrams here and then milliliters on the bottom. But what that means is on the right side, you have to also, this milligram has to be right next to the same as milligrams. And then on the bottom, this has to be milliliters on the bottom. And then you also have, very important, you must have one unknown. If you have two unknowns, you're going to have to do a little bit more conversion, but you should have one unknown and then three three known values. Okay, so you were given 30 milligrams, and then you have 0.3 milliliters, and then you have 40 milligrams, and then you have one. We got to figure out the milliliters, right? So you should have one unknown and three known values. Then in order to solve for x, you probably remember this from college algebra. Um, you can cross multiply because you only have two sides, right? You have the left side and the right. So you can just cross multiply like that. So 30 times x is 30x equals 2, and then 0.3 times 40. Okay, so this is going to be 30x, and then 0.3 times 40 is 12. Divide this by 30. So that would be 0.4 milliliters. So like we said before, you do have to include, so we're dealing with milliliters and it's less than one. So you do have to round to the nearest tenths. This is a tenths, right? And you do have to include this leading zero. Okay. We will do more examples on the next videos and you'll get the hang of it. Method three is the formula method. I really don't like this method. Formula method used for the following equation: desired over half times vehicle. You insert the order dose for D, available for dose of H, and medication form amount. Advantage. Um, so this is like basically where you move the decimal place, right? This is where you just move the decimal place, places to the left, places to the right. I really don't like this because I even get confused. But some people really do like this method. The advantage is this is a very straightforward way to solve basic dose calculation problems. Disadvantage, this method cannot be used for more complicated dose calculation. So you'll probably have to do met for more complicated, you'll probably have to either do method one or method two. So just make sure the units of measure are the same for the ordered dose and available dose. If necessary, convert the units of measure from for the ordered dose prior to setting up the equation. Insert the ordered dose as D, insert the available dose as H, include the medication form and an amount that it comes from in for V. Solve for the amount. So example using this formula, so you're just gonna um yeah, so it's desired over half times by vehicles. So let's say you desired 240 milligrams and then you have only 160 milligrams and then times it by 5 milliliters. You're just basically moving the decimal places either to the left or to the right. That's it. Since, for example, and then you get 7.5 milliliters. So yeah, you're just moving the decimal places to the left or right. Since we are given 5 milliliters, which is a greater than 1 milliliters, you must round to the nearest tenth. So that's also important. Yeah, so if you have less than greater than 1 milliliters, you must round to the nearest tenth. So remember what is being asked carefully. Some of the numbers provided might be irrelevant. So when we're doing calculation dosage, especially when we're doing more complex problems, there will be some numbers that just will be irrelevant, like you don't really need it. Just use what you need to answer the question. So this is, yeah, when you're dealing with these, just look at this overall. And also important, mind your zeros. In dosage calculation, a leading zero is a zero that comes before the decimal point when there is nothing in the ones place. For instance, 0.5 has a leading zero, while zero point 0.5 does not. A trailing zero is one that comes at the end of the number, and for the instance, 0.50 has a trailing zero. So trailing zero are after, and leading zeros are before. Okay? And make sure to include a leading zeros in your answers, but never a trailing zero. So also put that in your notes. Make sure you include a leading zeros in your answer, but never a trailing zero. For example, 0.5 milligram is correct. However, zero point 0.5 or 0.50 or zero point 0.50 is incorrect, right? So when you do these problems, it'll say it was wrong, right? So, also when rounding, only consider the number next to what you are rounding to. For example, read round 1.3455 to the nearest tenth. So you kind of need to know where your tenth place. So 3 would be your tenths, right? What you want to do is look at the neighbor. If it's 5 or beyond, you round. If it's less than 5, you do not round. So as you can see, 4 is not 5 or beyond, so you don't round. So you do not need to consider you do not need to consider the 5 in the thousands place. So Also check for plausibility. Try guesstimating. The answer is in the same ballpoint. So you might want to talk with other colleagues or even ask your teacher. Um, 'Cause sometimes it's just way off, like, right? You just kind of know. Um, yeah, if it is way off, you might want to double check your work. Okay. So yeah, we kind of over in this video, we kind of briefly went over the three methods and significant figures and leading zeros and trailing zeros. So in the next video, we will start doing some practice problems. Okay, I'm going to stop here.